Welcome back, everyone. Moving on to the next problem. We have to find the midpoint between -4, -6, and 12 and -2. And then once we have that midpoint, we have to use the length formula to verify that it's the correct midpoint. So just to give a quick overview of what we're going to do. So we got these 2 points here, -4, -6, and then we have 12, -2. What we got to do is we first got to find the midpoint between them, which is going to be here, right? Some kind of x and y value. And then once we have the midpoint, we have to verify using the length formula that it's the correct midpoint. So what does that mean? Well, if this is the midpoint here, notice that the length of this line and the length of this line is going to be the same. Let's actually label these. So this would be like A, B, and then we could call the midpoint M. So if this is going to be the correct midpoint that we get, that means that the length of AM has to equal the length of MB, or let's just say BM. Put it in alphabetical order. Okay, so both of those lengths have to equal, so that's one way to verify it. Another way is that these two lengths here, they have to be 1/2 of the length of AB. Okay, so we're actually going to do 3 length calculations. We're going to calculate the length of AM, the length of BM, those two should equal, and then we're also going to calculate the length of AB, and then these two lengths here should be 1/2 of this length, of the total length, right? Because these two lengths are going to be the same. So that's how we're going to verify with the length formula. So the first step is finding this M value, this midpoint. So the way we do that is we add up the X values of the endpoints divided by 2, add up the Y values of the endpoints, and divide it by 2. So we would have -4 plus 12 divided by 2, right? The 2 X values of the endpoints. And then we'll have -6 plus -2, and then we're going to be dividing by 2, like that. So -4 plus 12, that gives us +8, divided by 2 gives us 4. -6 plus -2, that's like -6 minus 2, right? This plus and minus turn into a negative. -6 minus 2 gives us -8, divided by 2 gives us -4, like that. All right, so 4 and -4 is the midpoint of A and B, of those 2 endpoints that we were given. So we found the midpoint. Now we're going to find the lengths of AM, BM, and then AB to verify that it's the correct midpoint. So let's start off getting the length of AM. Now, just the length formula in general, what's that equal to? Well, it's the square root of x2 minus x1 squared plus y2 minus y1 squared, like that. So the length of AM would be the square root. So let's let this be x1, y1. We'll let this be x2, y2. So we'll have x2, 4, minus x1, which is -4. So make sure you put that in brackets there. And then we're going to square that. And then we're going to have y2, which is -4, minus y1, which is -6. So make sure you put that in brackets right there. Okay, so from here we would end up with 4 minus -4 is like 4 plus 4, which would give us +8. That's going to be squared. And then over here we'll have -4 minus -6, which is like -4 plus 6, which gives us +2. And then that's going to be squared, like that. So what we would end up with is the square root of 64 plus 4, right? 8 to the power 2, 64. 2 to the power 2 is 4. So this would end up giving us square root of 68, like that. Okay, so that's the length of AM. Let's keep track of these on the side here. We're going to have the square root of 68. Okay, now what about the length of BM or MB, this line right here? So same thing, we're going to have the square root. Now we already let this be x2, y2, so I'm going to let this be x1, y1. It doesn't matter which ones you choose to be x1, y1, x2, y2. In the end, you'll end up getting the same length. But since we already labeled it here, I'm going to let this be x1, y1. So we'll have x2, which is 4 minus 12. That's going to be to the power 2. And then we're going to have y2, which is negative 4 minus negative 2, y1. And that's going to be to the power of 2, like that. So over here, we would end up 4 minus 12 is negative 8. That's going to be to the power 2. And then over here, negative 4 minus negative 2 is like negative 4 plus 2, which gives us negative 2. And that's going to be squared. So we would end up here with 64. Negative 8 to the power 2 is positive 64. Negative 2 to the power 2 gives us positive 4. And notice that we get the same thing, the square root of 68. So as expected, the length of AM and the length of MB or BM are the same. You can get the decimals if you want of these as well. I'm keeping them as exact values, but sometimes solutions may have the decimals, so you could just plug that into your calculator and get the decimal values. So as expected, those two lengths are the same. A lot of times this may actually be enough depending on your teacher. They may just want you to find these two lengths, make sure that they're both the same, and that would verify that that's the correct midpoint. But some teachers want you to take it a step further and actually find the length of AB and make sure that these two lengths are half of the length of AB. So I'm going to show you how to do that as well. So finding the length of AB, we're going to use that same formula. So you're not getting confused here. This is x1, y1, so I'm going to let this be x2, y2. Again, it doesn't matter. You could let this be x2, y2, and that x1, y1 as well. In the end, you should get the same length. So plugging it in, we'll have x2 minus x1, so we'll have 12 minus negative 4. Be careful with your brackets here. And then we'll have y2, which is negative 2, minus y1, which is negative 6. That's going to be in brackets, and then you're going to square that right there. So this would end up being what? 12 plus 4, which would give us 16. That's going to be squared. And then we'll have negative 2 plus 6, which would give us positive 4 over here, right? Negative 2 minus negative 6, those two negatives turn into a positive. Negative 2 plus 6 gives us positive 4. So over here, 16 to the power 2 gives us 256. And then 4 to the power 2 gives us 16. So we end up getting the square root of 272 for the length of AB. Now, here is where things can get perhaps a little tricky. Now, some teachers, they may just want you to get the decimals at this point. So if you get the decimal of the square root of 68, it's going to be like 8 point something. And then you can get the square root of 272, and that's going to be 16 point something. And if you get the decimal values, you'll see that this is double that right there. But a lot of teachers want you to also perhaps show it with exact values. So how can you tell, let's say you didn't have a calculator, how can you prove that the square root of 272, half of that is equal to the square root of 68. Let's say you didn't have a calculator and you could only use these exact values, right? These square root or radical forms. Well, there's a couple of ways to do it. Before actually doing it, I want to go over some fundamentals of square roots. Now, square roots, let's say that you have the square root of a times the square root of b. That's actually going to equal the square root of AB. And then you could test this out with certain numbers. So notice that, let's think of a rootable number 4, and then we got root 9. Okay, if you just do these separately, what's root 4? That's 2. Root 9 is 3. So notice that these multiplied would give you 6. But what if we took this and used this rule over here? Well, the square root of 4 times the square root of 9 is going to give us the square root of 36. And then what's the square root of 36? Well, it's 6. Okay, so that's another way to go about it. And so to show the relationship between these, we're going to have to use this, this formula here, this rule. So one way to do it is, what we can do is we could take the square root of 68 and we can multiply it by 2. And we know that the square root of 68 multiplied by 2 has to give us the square root of 272, right? Because the square root of 68 is half of the square root of 272. You could verify that with a calculator, right? You'd get 16 point something here. I think it's like 16.4. And then square root of 68 is going to be 8 point something. And you can see with the decimals. But again, the question is, how do we do that in this radical, in this square root form? Well, what we can do is, notice that we can't multiply at this point the square root of 68 times 2. Because to multiply a radical, you have to multiply by another radical over here. So how can we take this 2 over here and change it so it's the square root of something? Well, 2, if you think about it, that's the same as the square root of 4, right? Square root of 4 is 2. And so square root of 68 times 2 is the exact same thing as the square root of 68 times the square root of 4. And now that we're multiplying two square root terms, we can multiply the two values under the square roots together. And 68 times 4 does indeed give us 272. Okay, so that there is how you can show it, right? Because we know that this length is half of this length, so that means this length times 2 has to give us that. And that's how you can show it without using a calculator, without getting the decimals. Again, your teacher may just allow you to do that, but just in case your teacher doesn't, wants you to show it this way, this is how you do it. Another way you can do it is you can take the square root of 272 and you can break that down. You can go the other way. So the square root of 272, that's actually equal to square root of 4 times the square root of 68. You could take 272 and then you could start breaking it down into certain factors. But you want to make sure that the factor you're breaking it down to is 4 because you need that 2, right? To show that 2 times the square root of 68 is going to be this. So for example, if we took 272 and divided it by 2, what would that give us? That would give us like 136. That's not going to work, right? Square root of 2 times the square root of 136, right? square root of 2 is not a smooth number. It's not going to give us 2. So those aren't the factors you want to use. You actually want to use the factors 4 and 68. That's what you want to break the 272 down into. Okay, and then once you break that down there, then you'll have 2 times the square root of 68, right? Which shows that 2 times this value gives us this, which shows us that half of this value ends up equaling the square root of 68, right? If we put a half here the whole time, and then we add a half over here, and then we add a half over here, notice that the half and the 2 would just be 1, and then we'd end up with the square root of 68, right? Half of this is the square root of 68. Okay, so 2 different ways to show it. Personally, I prefer this way, but this is another way that it might be shown in your textbook, or your teacher might show it this way. So multiple ways to go about it, but that's the process of verifying it in all scenarios, whether you're going to just verify with the decimals, which is the easiest way to do it, but your teacher, again, may expect you to be able to work with these square root exact values.